All right, Algebra 1, we just spent the majority of Chapter 7 learning how to factor. Just as a very quick review, we learned how to break things down into prime factorization. We learned how to find a greatest common factor and take it out using the distributive property. We learned how to factor something that's a trinomial a couple of different ways. We did a guess and check method. We used a sum and product chart method. And occasionally we were able to find out that it was a perfect square trinomial, and we were able to use that method, that pattern, using the 3 questions. And then we also saw if something was a binomial, what could we do? We could look for difference of squares. So we talked about lots of ways to factor for the majority of Chapter 7. And so this ending to the chapter is why we've been learning to factor. And so now we have equations. We haven't had an equation this entire chapter, so we haven't had an equal sign anywhere. We haven't solved for x or whatever the variable is. But now we're getting to the point where we're going to have an equal sign, and the goal is going to be to take it a step further and to find out what x or y or whatever the variable is, we're going to be solving for that variable. So we're learning a property today called the zero product property. It says for all numbers a and b, if a times b equals 0, then a equals 0, b equals 0, or both a and b equals 0. So let me hopefully make this more sense. That didn't even sound like correct English, so I don't even know what I just said. If you're multiplying 2 numbers, 2 values, and your answer is 0, then it would make sense that one of these at least had to be 0. Because how else do you get a product of 0? You have to multiply by a 0 to get a final product of 0. So this just says if your equation equals 0, then one or both of your factors have to equal 0. That's all the zero product property states. So for example 1, you'll notice that we have an equation because we have an equal sign. We have it already set equal to 0 on the right side, and on the left side it is already in factored form. The factoring has already been done for us. So it says solve. We're going to solve this equation, and then we're going to check the solutions. So the solving part goes to what we just learned right here, which says if a times b equals 0, then a could be 0 or b could be 0. So let's identify the factors for this problem. In our first set of parentheses, we have y plus 2. That's a factor. In the second set of parentheses, we have 3y plus 5. That's another factor. Remember, I've been using the word factor in this chapter a lot. Factor means what are you multiplying together? Those are the 2 things that we're multiplying together. Y plus 2 times 3y plus 5. So we're going to take each factor, and according to the zero product property, we're going to set them both equal to 0. So we're taking each individual factor, and we're going to set them both equal to 0, and then we're going to solve for y. So this first one's pretty easy. If we subtract 2 on each side, we're going to get that y equals -2. For the second one, we're going to subtract 5 from each side. So we have 3y equals -5. Then we're going to divide both sides by 3. That doesn't go in there evenly, and it's already reduced, so we're going to leave it as y equals -5/3. So now it says check. So we're going to go and check. So I'm going to start with the first one, with y being -2. I'm going to go to the original problem, and every time I see a y, I'm going to put -2 in its place. So I've got 2, sorry, that should be -2, right? I'm plugging in a -2. -2 plus 2 in the first parentheses. And then I'm going to do 3 times -2 plus 5 in the second parentheses. Again, every time I saw a y, I plugged in a -2, and I'm going to put a question mark over the equal sign because that's our goal, is to figure out, does it in fact equal 0? Well, -2 plus 2 is 0. In the second set of parentheses, 3 times -2 is -6, and -6 plus 1 is -1. And what happens when you multiply 0 times -1? You get 0. So that one works. That is a solution. Now I'm going to check the other one. So every time I see the letter y, I'm going to plug in a negative 5/3. So I have negative 5/3 plus 2. And then I have 3 times negative 5/3 plus 5. And we're going to figure out, does that equal 0? Well, in the first set of parentheses, if I'm going to add these together, I need a common denominator. So I'm going to turn the 2 into a 6/3. Negative 5/3 plus 6/3 gives us a positive 1/3. In the second set of parentheses, 3 times negative 5/3, the 3's would cancel out. I would be left with just a negative 5 plus 5, which is 0. What happens when we multiply 1/3 times 0? We get 0, and that answer also works. So we have 2 solutions, not just one, and we use the zero product property to solve and check. So let's take a look at example number 2. Again, it's already set equal to 0. It's already factored for us. So again, we're going to take each factor and set it equal to 0. All right, so for this first one, we're going to subtract 4 from each side. So now I have 2a equals negative 4. And then we're going to divide by 2, excuse me, and a is negative 2. For the second factor, we've set a minus 9 equal to 0. We're going to add 9 on each side, and I get that a equals 9. So I have 2 solutions. Let's start with the negative 2, and we're going to go back to the original problem and plug in a negative 2 every time we see a. So 2 times negative 2 plus 4 in the first parentheses. Negative 2 minus 9 in the second parentheses. So 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Negative 2 minus 9 is negative 11. And if we multiply 0 times negative 11, we get 0. And so that solution does work. All right, let's try the 9. So I'm going to have 2 times 9 plus 4 in the first parentheses. 9 minus 9 in the second parentheses. 2 times 9 is 18, and 18 plus 4 is 22. 9 minus 9 is 0, and when we multiply 22 times 0, we get 0, which makes that also a solution. So we get 2 solutions for example number 2. All right, example 3 is different. There are 2 ways that make this different. First of all, this equation is not already equal to 0. Remember, the zero product property means that it has to be set equal to 0. So the first thing that I need to do is get everything on one side. Typically, and this is just my personal preference, if there is a variable that's squared, I like for it to be positive. And since this is already positive on the left side, I'm going to keep it on the left side, and I want to move the 11k over to the other side. How do I move a positive 11k? That's easy. I'm going to subtract it. So I'm going to subtract 11k from each side. On the right side, those 2 things cancel out. We now have 0, which is what we want to have if we're going to use the zero product property. It has to be set equal to 0. On the other side, those things are not alike. Remember, in order for things to be like terms, they have to have the same variable, but that variable has to have the same exponent. And here we have a k to the second power and a k to the first power, and these are not alike. So I'm just going to write what I see, k squared minus 11k. Notice I have it in descending order. Again, that's a preference that I have. I like to put it from a highest exponent and work my way down. Now let's talk about what we've been practicing this whole chapter. What's the first thing I always ask you guys to look for? That would be a GCF. Do we have a GCF? We're ignoring the equals 0. We're just focused on the left side of the equation. Is there a GCF? Yes. Each of those have a k. So I'm going to take it out using the distributive property. Remember, this is where you're dividing it out. Well, this first term was k squared, but if I divide out a k, I'm left with only having 1 left. Remember, k squared means k times k. So if I take 1 out, I only have 1 left. The next term, I have minus 11k. If I divide that by k, I'm left with minus 11. Now, all we've done so far is we've identified the GCF. We took it out using the distributive property. Then I would look, and this is what we did in the first part of the chapter, and I would say, can I take that k minus 11 and factor it any further? Well, it's a binomial, which means it has two terms. So what do we look for? We look for the pattern called difference of squares. Is k minus 11 a difference of squares? No, it's a difference, but k and 11 are both not perfect squares. So this is as far as you can go with factoring it. Here's where we pick up the new lesson, which is take each factor. Remember, factors means what have you multiplied together? That's the k and the k minus 11. We're going to take each factor, and according to the zero product property, we're going to set each one equal to 0. Now, the first one, when you set it equal to 0, you're done. The second one, we need to solve for k. So I'm going to add 11 to each side, and I get that k equals 11. So now comes the part where we're going to check our solution. So again, I'm going to go to the original problem. I'm going to start with k equaling 0. So my original problem, I'm going to have 0 squared. Does it equal 11 times 0? 0 squared is 0. 11 times 0 is 0. Yeah, absolutely. That is a solution. It works. All right, let's try the other answer of 11. Again, we're going to go back to the original problem. So I'm going to have 11 squared. Does it equal 11 times 11? 11 squared is 121. 11 times 11 is 121. It absolutely works. So again, I've got those two solutions. Let's take a look at example number 4. So first thing I'm going to do is check to see if it's equal to 0, which it is. So we're in good shape. Then I'm going to look over here at m squared minus 8m minus 33. Does it have a GCF? It does not. So I have a trinomial. The three options are guess and check to see if it's a perfect square trinomial, or do a sum and product chart. I'm going to go into a sum and product chart because that method is the one I tend to like the best. So remember, the sum comes from the middle coefficient, which in our case is a -8. The product comes from the beginning and the end. So the 1 that's in front of the m squared and the -33 at the end, we're going to multiply those together to get -33. So I'm looking for two numbers that are going to multiply to be -33, but we want them to add to be -8. So let's see, -11 and 3. If you multiply those, you get -33. If you add them, you get -8. So first try, I was able to get it. We want to put them both over the leading coefficient. Our leading coefficient is a 1 because there's an understood 1 to be in front of the m squared, which also means I don't have to reduce. So remember, when we use this method, the denominator goes in the front, the numerator goes in the back, and for us, the variable is going to go in the front because that's where the variable is in our problem. So my first factor is going to be 1m minus 11. My second factor is going to be 1m plus 3. Don't forget, you still have the equal 0. So far this is a review of what we've done earlier in the chapter. We just have something new to finish it out with because now we have to take each factor and set them equal to 0. So for m minus 11 equals 0, I'm going to add 11 to each side, and I get that m is 11. For the m plus 3 factor, I'm going to subtract 3 from both sides, and I'm going to get a -3. So let's check and see how this is going. I'm going to start with the 11. Again, I'm going to go to the original problem. So I'm going to have 11 squared minus 8 times 11 minus 33. Does that equal 0? 11 squared is 121 minus 88 minus 33 equals 0. 121 minus 88 is 33, and 33 minus 33 is 0. So guess what? That one works. All right, let's try the m equals -3. So I'm going to have -3 squared. Notice I put that in parentheses. That just goes back to chapter 1 and chapter 2. You want to make sure you put it in parentheses because you're squaring not just the 3, but you're squaring the negative with it as well. Minus 8 times -3 minus 33, does it equal 0? All right, -3 squared turns into 9. In the middle, negative 8 times negative 3 turns into positive 24. And then behind it, we still have minus 33. 9 plus 24 is 33. 33 minus 33 is 0. And yes, it works. Now, interesting fact to show you here real quick. If you look at both of these problems, what was the highest exponent that you saw? For this problem, we saw an exponent of a 2. For this problem, we also saw an exponent of a 2. And for both of these problems, how many answers did we get? 2. So when your exponent is a squared, then you're probably going to have 2 answers. All right, let's take a look at example number 5. We have y squared minus 81 equals 0. The good news is it's already set equal to 0. There is not a GCF. And because it's not a trinomial, we can't do guess and check or sum and product chart or even the perfect square trinomial pattern. But we can look to see if it's a difference of squares. It's a difference because there's a minus sign. What could we square to get y squared? You could square a y. What could we square to get 81? That would be a 9. So according to the pattern that we learned earlier in the chapter, we need one of these to have a plus and one of these to have a minus. So again, that's review from what we did on the last test. Now we're going to take each of those factors and we're going to set them equal to 0. So for this first one, we're going to subtract 9 from each side and we get y is negative 9. For the second factor, I'm going to add 9 to each side and I get y equals positive 9. All right, just for sake, so let's go back, plug in the negative 9 first. So I have negative 9 squared minus 81. Does it equal 0? Negative 9 squared is 81. 81 minus 81, does it equal 0? Yes, it does. Second solution we're going to try is 9. So we're going to have 9 squared minus 81. Does it equal 0? 9 squared is 81. 81 minus 81, does it equal 0? Yes, it does. Again, 2 solutions. Why? Because our exponent was a 2 in that problem, and that means that we have 2 answers. All right, number 6 is different because it is not set equal to 0. I want to get everything on one side and 0 on the other side. One of the hints I kind of told you earlier was whatever your variable is that's squared, you like to keep that positive. This over here is already positive, so I'm going to choose to keep it where it's at, and I'm going to move the 5r over and the 24 over. So in order to do that, I'm going to subtract the 5r as well as subtracting the 24 from each side. As I write this down, I'm going to write it in descending order. So I have r squared minus 5r minus 24 equals 0. So I have it in descending order. These were not like terms because they didn't have the same exponent, so that's why it's written in this form. There's not a GCF for that trinomial, so I'm going to go into a sum and product chart. My sum is negative 5. My product is negative 24. I want to find 2 numbers that are going to multiply to be negative 24, but add to be negative 5. So if I used a negative 8 and a positive 3, that would work. I'm going to put both of those over the leading coefficient of 1 because there's an understood 1 to be in front of the r squared. Remember, your denominator goes in the front, your numerator goes in the back, and our variable will also go in the front because that's where our variable is in the trinomial. So I will have 1r minus 8 times 1r plus 3. Don't forget the equals 0 on the right. So again, all of that has been practiced for what we've done earlier in the chapter, and now the new part is to take each individual factor and set them equal to 0. So if I add 8, I get that r is 8, and if I subtract a 3, I get that r is negative 3. So let's go to the original problem and check it out. So I'm going to have 8 squared. Does that equal 5 times 8 plus 24? 8 squared is 64. 5 times 8 is 40. And 40 plus 24 does equal 64. So r equals 8 is a solution. Now I'm going to check the other answer, which was a negative 3. Again, I'm going back to the original problem. So I'm going to have negative 3 squared. Does that equal 5 times negative 3 plus 24? Negative 3 squared is 9. 5 times negative 3 is negative 15. And when we add negative 15 to 24, we get 9. So yes, that one is a solution as well. Okay, number 7. So good news is it's already set equal to 0. Bad news for some of you is that you don't particularly like fractions. But when we did this type of problem earlier this year, I did teach y'all a way that you could avoid fractions, and that is to find what the common denominator would be and multiply it on both sides. So I think the common denominator would be a 12. So I'm going to multiply both sides by 12. Now on the left side, that means that I have to do the distributive property. So I'm going to show my work here. I'm going to do 12 times x squared over 12 minus 12 times 2x over 3 minus 12 times 4. And on the other side, I have 12 times 0. So for this first term, the 12s are going to cancel out, and I have x squared. For the second one, the 3 goes into 12 4 times. I did cross canceling there, and 4 times 2x is 8x. Then I have minus 12 times 4, so that turns into a 48. And on the other side, 12 times 0 is still big fat 0. So we've gotten rid of the fractions, which is good. And now let's see how we can factor this. There's no GCF. We can do a sum and product chart. The sum would be negative 8. The product would be negative 48. So I'm looking for two numbers that are going to multiply to give us negative 48 and add to give us negative 8. So let's see. If I did a 12 and a 4, that would give us 48, but I need a negative 48, so one of those numbers needs to be negative. I think 12 should be negative because I want to add those together and get a sum of negative 8. So it looks like I've got my two numbers. Both of them are going to go over 1 because we have an understood 1 in front of the x squared. So I'm going to have 1x minus 12 times 1x plus 4 equals 0. So we have it in factored form. Now the new stuff, set each factor equal to 0. So the first one, if I add 12 to each side, I get that x is 12. For the second factor, if I subtract 4 on each side, I get that x is negative 4. And it says check our solution. So let's do the 12 first. Again, I'm going to go to the original problem right here. So I'm going to have 12 squared over 12 minus 2 times 12 over 3 minus 4. Does that equal 0? Okay, so 12 squared is 144, and 144 divided by 12 is 12. 2 times 12 is 24, and 24 divided by 3 is 8. So if we now go left to right, 12 minus 8 is 4, and 4 minus 4 is 0, and 0 equals 0. So 12 is one of our solutions. Let's check the other solution, which is negative 4. Again, I'm going back to the original problem over here. So I'm going to have negative 4 squared over 12 minus 2 times negative 4 over 3 minus 4. Does that equal 0? All right, negative 4 squared is 16. 12 does not go into 16 evenly, but we can reduce that to 4/3. Minus 2 times negative 4 is negative 8 over 3. Now what's going to happen right here because of those two negative signs? I'm going to go and turn that into a plus. And then I have minus 4. Well, right now that 4 is like a 4 over 1. It might be helpful if we go ahead and write it as a common denominator. So I'm going to change 4 over 1 to 12 over 3. So now let's go from left to right. 4/3 plus 8/3 is 12/3. 12/3 minus 12/3 does turn into 0. So we have, again, two solutions because our exponent of our variable was a squared. All right, example 8, 9, and 10 are all word problems, so let's take a look. Now remember, we've been working on word problems a lot this year. We always start by defining our variable, saying what we want x to represent, or a different variable if you choose. So let's read this problem together. It says the product of twice a number and 3 less than the number is 0, find the number. So what are we trying to find? We're trying to find a number. So I'm going to start off with saying let x equal the number. All right, let's look at some key words. One word that I see is product. We know product means when you multiply things together. So I'm clearly multiplying things together. What am I multiplying together? I'm multiplying twice a number. Well, if the number is x, what does it mean when you say twice that value? That means you're multiplying by 2. You're doubling it. So I'm going to multiply 2x, so twice the number, and 3 less than the number. We talked about this phrase less than earlier in the year, and remember I told you when you see that phrase less than, you want to flip your order. So instead of 3 minus the number, we're going to flip the order and change it into the number minus 3. And we're multiplying the twice the number and the 3 less than the number. So I have 2x times x minus 3, and then is, we know, means equals 0. Now the great thing about this particular problem is it's set equal to 0, and it's already in factored form. We don't have to do any work as far as finding the GCF and figuring out how to factor it. It's already done for us. So we're going to set each factor equal to 0. So because it was already in factored form, we did not have to do that step. We're just setting each factor equal to 0. So for the first one, I'm going to divide both sides by 2, and I get that x is 0. For the second one, I'm going to add 3 to each side, and I get that x is 3. So to answer the question, when it says find the number, my number could be 0, or it could be 3. 2 different options for that word problem. Let's take a look at example number 9. It says the product of 12 times Carl's age less 72 and twice Carl's age is 0. How old is Carl? All right, so I'm going to start off by saying that x is going to represent Carl's age because that's what it is that we're looking for. Now you can use a different variable if you want, like k. I'm just going to stick with x. Again, I see that keyword of product. So that tells me that, again, we're going to have some multiplication going on. So let's figure out what are the 2 things that we're multiplying together. Well, the word and separates them. So this is one thing we're going to multiply, 12 times Carl's age less 72. And the other thing we're going to multiply by is twice Carl's age. So those are the 2 things we are multiplying. Let's start with the first one. 12 times Carl's age less 72. You know, in the last problem we had the phrase less than, and we flipped. This is just the word less, and when we talked about this in an earlier chapter this year, I told y'all that the word less by itself, without having let than behind it, just means minus. So this is like 12 times Carl's age minus 72. What would that look like? 12 times Carl's age, right there, I'm going to multiply 12 and the x, and then less minus 72. That is one of the factors that's being multiplied together. Now, what are we going to multiply that with? Twice Carl's age. And if Carl is x, then twice that would be 2x. And then it says is, so that means equals 0. So again, the thing I love about this problem is it's already set equal to 0, and it's already in factored form. We don't have to factor it any further. At this point, we're going to set each factor equal to 0. All right, let's start with factor number 1. What would we do? Well, we would add 72 to each side. So we have 12x equals 72. Then we would divide each side by 12. So we have x equals 6. Over here, what would we do? We would divide both sides by 2, and we would get x equals 0. Now remember, in this problem, it doesn't just say what's a number or what's the number. It says how old is Carl. which answer doesn't make any sense, because he can't be two different ages, can he? You're not two different ages. I'm not two different ages. Which answer doesn't make sense? The 0 doesn't make sense, because that means you're not born yet. You're not alive yet. So for our answer, we're going to say that Carl is 6 years old. That answer would be the only one that would make sense. So anytime you're doing a word problem, again, you want to check and make sure, have I answered the question that I've been asked? And does my answer make sense? You always want to ask yourself those two questions, because if your answer doesn't make sense, then that might potentially mean that you've done something wrong in the problem and you need to go back and redo it. But for us, the 6 makes sense, but you can't be two different ages, and you certainly can't be 0, because that means you weren't even born yet. Okay, last example. It says when one integer is added to the square of the next consecutive integer, the sum is 1. Find the integers. All right, this one's a little bit more challenging, so I'm going to try to walk through it a little bit slowly with you. We are being asked to find the integers, so let's go back and see what it says. It says when one integer is added to the square of the next consecutive integer. So let's talk about this. I'm going to start by saying let x equal the one integer. So this guy right here, I've just called him x. Okay, so it says when one integer, otherwise now known as x, is added, so I'm going to put a plus sign, to the square. What does square mean? It means I'm going to have an exponent of 2, right? I'm raising something to the second power. I'm squaring it. But what are we squaring? It says we're going to square the next consecutive integer. Now, we talked about consecutive integers earlier this year. Remember, we said consecutive integers means one right after the other. So if x is one integer, what would the next consecutive integer look like? Well, it would be x plus 1, right? If x is one of the numbers, then the next number is one bigger than it. It's like if I have 4, how do I get from 4 to 5? I add 1. So the next number is x plus 1, but what are we doing with that number? We're squaring it. Okay? So we took the next consecutive integer and we're squaring it. All right, so let's look at this again. It says when one integer, which we called x, is added to the square of the next consecutive integer, the sum, that means it's equal to 1. All right, there's a couple things that make this problem different. First of all, this is not a 0, and we're going to need it to be a 0, but we'll do that in a moment. Secondly, we have x plus 1 squared. Now, when we were in chapter 6, there were a lot of you who made a common mistake on your test. You took that squared, and over here, you tried to distribute it into the parentheses. And I very distinctly remember telling you guys that the only time you're allowed to take an exponent on the outside of parentheses and distribute it to what's inside of the parentheses is if you have multiplication or division happening. Here you have a plus sign, and that is no good. What does it mean, though, if you square something? Well, it means that you're multiplying that x plus 1 times itself twice. So this is where we're going to be foiling. This is where we have a binomial times a binomial. So right now I'm still ignoring this x out in the front, and I'm also ignoring this 1 on the right side. I'm going to focus on foiling x plus 1 times x plus 1. So y'all walk along with me here. So for first, I would have x times x, which is x squared. Then for outer, I would have x times 1, which is a 1x. Then for inner, I would also have 1 times x, so I get another x. And then last, I would have 1 times 1, which is 1. So let's see if we can combine like terms. And as we're doing that, I'm also going to see about putting it in descending order. So my x squared, there's nothing like it, so it's going to remain just an x squared. But let's look at what I have, because I have some like terms right there, don't I? I have a total of 3 x's. And then I have plus 1 equals 1. Now before we can use the zero product property, this one over here needs to be a 0. Remember, that's why it's called the zero product property. So I'm going to subtract 1 from each side. And now I have x squared plus 3x equals 0. So what can we do with this left side over here of x squared plus 3x? Does it have a GCF? Absolutely. I'm going to take out an x, and that's going to leave us with x plus 3 as that factor. Now as I look at x plus 3, it's a binomial. Is it a difference of squares? No. So it's factored as far as it can go. Now we get to use the zero product property, which says take each factor and set them equal to 0. Well, this one's already solved, so I'm going to move over here, and I'm going to subtract 3 on each side, and I'm going to get that x is -3. So let's go back and take a look at what the question says. Again, it gave us that information. When one integer is added to the square of the next consecutive integer, the sum is 1. But here's what it's asking us. It says, find the integers. Well, you have two cases here. The first case is if x is 0. If x is 0, then x plus 1 would be 0 plus 1, which would be 1. So if that's the case, then my numbers would be 0 and 1. But then you have a second case, because we also found out, according to our math, that x could be -3. And if x is -3, then x plus 1 is -3 plus 1, which is -2. So our other answer for this problem is that the numbers could be -3 and -2. So we actually got two different sets of solutions. Our two numbers could have been a 0 and a 1, or our two numbers could be -3 and -2. All right, so that covers all of the notes for part 1. Tomorrow I'll have a video for part 2. This week is all about solving equations, so we're still using what we did the first part of the chapter, but now we have to take it a step further and use the zero product property. We have a test coming up on a Friday, because again, this is the only thing we're learning is now we have to solve. So we're still utilizing everything in chapter 7, but we're going a step further and solving. So I will talk to you guys in the next video where we do more practice with solving equations.